our studies with PRRS 144 lineage 1C. So we go to the first slide. Actually, the next slide. Uh, I would like to first thank a large group of people that if it wasn't for their help, for their sharing their information, we wouldn't be talking about this. And it's basically those participants of the Morrison Swine Health Monitoring Project, together with my team and the team of collaborators that we have within MSHIM. I would also like to acknowledge Schick, who provides our funds, the funds for our project, and then the 3 diagnostic laboratories that you see on this slide. So for those of you that are not familiar with the Morrison Swine Health Monitoring Project, is what I called a voluntary project by producers for producers, which is basically 38 companies that I'm just showing here by depicting company A to E that have shared with us farm location, type of farm characteristics, whether they're filtered or not, their health status, and they have kindly agreed to give us a weekly update on whether their health status of those farms has changed, whether it's an outbreak or whether it's reaching instability or eliminating a pathogen. So what we do on a weekly basis is we get all that data, we bring it into the database, and then the MSHIM team conducts some data analysis that ends up generating 3 outputs. One of them is continue to prepare the database, which is basically getting a database ready in case there's a foreign animal disease emergency. We also produce weekly reports that get sent out to the industry, and we also conduct research. So in this occasion, I think we're going to fall into the research arena. So all this started during the fall and winter of 2020, when producers and veterinarians started telling us that they had been seeing this event. Well, that event went all the way to spring and summer 2021. Basically, what happened is that there were simultaneous outbreaks, PRRS outbreaks, of course, in a specific region. It all started with growing pig barns, pigs becoming really, really sick, coughing, high death losses, and then they started seeing something similar in breeding herds. Of course, because of the nature of the area where this started, there were some farms that were sow farms that were filtered, and then as it started spreading, it reached out some multipliers, and in these farms we could see that there was some high impact as well. Interestingly enough, this event was clustered in time and space. We could see that it was spreading rapidly, but the other important thing is that I don't think it has been very well documented in the past, is that we saw that the sequence originating from all these outbreaks was pretty much identical. Yes, it was classified as an RFLP 144, but I just want to remind you that that doesn't tell us much. Nowadays, we're trying to classify viruses in a better way, and we're using lineages. So this virus fell into the lineage 1 and sublineage 1C. So that's why it was characterized this way. However, at the same time, across the United States, not across, but in a specific region in the United States, we obtained reports of another 144 virus generating some losses, which was completely unrelated to this lineage 1C virus. So this is just an example of data that was shared to us from a company, in which we can just see how important the productive impact has been in some of these sow herds. So if you focus on the red line, all these sow farms, you could see that there's an important increase in the pre-weaning mortality. And then if you focus on the black line, which is just summarizing the percentage of mummified fetuses that were reported, we can see that there's quite a lot of mummies. There were a lot of mummies being produced during these outbreaks, right? When we see that in those same farms, when we look at the farrowing rates and then the number of abortions, we can see that some of those farms were heavily impacted by this virus, of course. In some other farms, we didn't see much. So that's kind of something that needs to be better understood. However, the impact of this virus in the breeding herd farms was pretty significant. I don't have any data for the growing pig farms, but we do know that wean to market mortality was reaching the double digits, and in some cases above 40%, which was kind of significant. So this took us to another level in the sense that we needed to characterize what was happening with this epidemic, and this is work from Dr. Mariana Kikuchi from my team, and she led all the efforts on when it comes to characterizing what was happening. So we started asking for data, started asking veterinarians and producers from our network to report to us any changes in their status, of course, but also to share their sequences. And up until a certain moment, we were able to see that 284 sites were affected. Of course, this number is underestimating the real impact in the whole region or in the whole country, just because we don't have all the farms included in our database. Interestingly enough, of course, we had a mixture of breeding herds and growing pig farms. But if you look on the right, on the blue panels, you'll see that there were those sow farms that broke with this virus had different statuses, right? Some of them were vaccinated, some of them were not were unvaccinated, some of them already had another virus circulating. So we saw all the variability that we could ask for in that population. Now, we don't have the right number today, but we feel like this virus may have reached more or less 250,000 sows, maybe more than that. It's kind of underestimated at this point. And when we talk about the growing pig farms, again, it's hard to estimate, but we're talking about at least 500,000 pigs that were infected or impacted by this virus. This number, of course, does not reflect the reality in the sense that nowadays we continue to see more infections, and this virus continues to spread. Even though the number of cases seem to have gone down a little bit, we still need to wait what's going to happen during the fall. And this brings us to what we call the epidemiological trend, or the epidemiological curve. We do know that this strain had been around for a while, right? If you look at this graph in where we summarize the number of sequences per week, per calendar week, we can see that at the beginning of 2020, we can see in week 2 and 4, this sequence had already appeared. It went silent for a while. We saw it in the summer of 2020. And then at the end of the year is when the whole mess started. Interestingly enough, those first few cases, there was a sow farm that they went to the break. They thought it was a regular first break. Very responsibly, they eliminated that strain from that sow herd. And but then nothing happened for the next few months until we reached that fall winter of 2020, 2021. That's when we saw the first wave, followed by the second wave very strongly at the end of the winter, beginning of the spring into the summer of 2021. Next slide, please. When we look at that same data from a map perspective, we can see that most of the cases are clustered in southern Minnesota and northern Iowa. Of course, this is just a summary of all the cases, but I wanted to point out that at the same time we had that same strain, we had other PRRS strains circulating, right? And that's when we see the mixture of the purple dots being the purple dots lineage 1C affected farms, surrounded by the yellow ones, which were other strains, and surrounded by those that had not reported any PRRS in that same window of time. So we're always having a mixture of positive and negative populations, and within the positive, we have different strains circulating at the same time. Nothing that has been seen before. So this is just to show you where the cases have been reported. We do know that this virus continues to move across the Midwest. We have seen it in more states than what we're seeing here. It's just that we don't have those farms in our database. This is when the team led by Dr. Kikuchi started asking a lot of questions. I started asking questions as far as why is this virus spreading so rapidly, or why do we think it may be spreading so rapidly? So that's when she decided to go ahead and conduct what we call a case control study, in the sense that we wanted to compare the occurrence of lineage 1C versus other strains of PRRS, right? Just to see if we could pinpoint any differences from a transmission standpoint. So within the analysis, a lot of farm characteristics went into the analysis, in the sense that we wanted to include all the breeding and growing farms or growing pig farms that were affected by any kind of PRRS, whether they will filter or not, whether they were using feed mitigants. We also asked for the way they were handling the mortality or the manure during that time, any maintenance events that had occurred very close to the outbreak, and many other questions that may have been related to transmission. We couldn't find a specific, or we couldn't find one factor that kind of explained why this strain spread so readily and so fast throughout those regions. So we couldn't pinpoint a different transmission route if there was one, right? So that, which is kind of a good thing in the sense that there may not be another one. Maybe it's just the same transmission routes, but it was just better at transmitting. And this is where we start continuing to mapping. And of course, in your screens, you may be seeing little dots. We did that on purpose just to try to prevent or avoid people identifying specific farms. But what we wanted to show with this map is that the lineage 1C farms are very close to negative farms, or those green farms that you see on the map. But also there's some yellow dots in there which are representing other strains. One thing that we continue to ask ourselves is, yes, the red dots are clustered in time and space, but there's also green and yellow dots very close to the red dots, which begs the question of why does the yellow dot strain did not spread further? One question there that we don't have a good answer for. But also the green dots, which are, to me, they're kind of the more interesting one in the sense that, yep, why didn't those farms break with lineage 1C? There could be many theories. We could speculate quite a bit about that event. But it's interesting because when we look at transmission, we always assume that transmission is going to occur in a specific manner. Well, here we have an example that in that we think we know how PRRS transmits, but I feel like we still need to learn a little bit more about it, just because there's farms that are negative to lineage 1C that are very close to positive farms and they didn't get infected. Up until today, some of these farms continue to be survivors, like I would like to call them, just because they went through two massive waves of challenge or viral pressure in those regions. So when we look at the aftermath of this, and some of you may have seen this graph before, this is one of the graphs that we generate with our report. We know that PRRS has had a consistent and predictable pattern throughout more than a decade, right? So here you see on this graph, on the x-axis, you see that we go from July to June. That's kind of our fiscal year. And then on the y-axis, we have incidents. In our case, this is cumulative incidents. Pretty much, we count every case on a weekly basis, and we just do it from a cumulative standpoint. And at the end of the day, at the end of the year, we can tell the industry what proportion of those breeding herds in our project reported an outbreak. So there you can see on the purple bracket that 75% of the time, on a yearly basis, pretty much between 20 and 30% of the herds report a break, right? But if you focus yourself on the light green boxes, and that's, I'm just highlighting there the 2020, 2021 MSHMP year, we can see that that gray line behaves pretty much the same way during the fall, during the winter, but then during the spring, summer, or into the summer, there's a steep increase. If it hadn't been for that, maybe we have ended around 20% from an incidence perspective. So that's kind of interesting. So that's kind of the aftermath and the impact of this virus. And we look at that data from a different perspective. And this is just, some of you may have seen the CDC human flu curves or epidemic curves. This is pretty much the same approach, right? In the sense that we like to understand when the epidemic starts and when does it end. So there you see a red line, which we use as a threshold, right? So once we cross that threshold, it means that we're seeing more cases than expected, and that's kind of already telling us, okay, the epidemic it started. There you can see every single peak that started either in November or October of every year, right? So that's kind of the little clock. It's every October and every November where we see an increase on the frequency of cases reported. If we hit next, we will see that in the last year, you'll see that, yep, we started seeing an epidemic in the 28th of October of 2020, which is perfectly fine. It ended around the same time, but then we saw another important epidemic. So that's already telling us this virus is behaving a little bit differently just because it changed the trend that we had seen for the last 10 to 12 years. So we kind of gave him the opportunity to spread perhaps, and that's important to keep in mind. So at the end, what did we learn about this new lineage? I don't think this is a new event. We do know that these viruses tend to evolve. We know that every 4 or 5 years, we're going to see a new strain raising their hand and testing the waters and see if they can transmit efficiently or not. This is an example, right? So lineage 1C did it this time. A few years ago, it was the 174s, like you may remember. So that's what we learned. Okay, it reminded us that this happened last year. It may happen again in the coming years, right? However, in this case, it's just started as a regional outbreak. Yep, we never expected to find them so clustered in both in time and space. So that was kind of interesting. We didn't find any specific factors that we could associate to transmission. It's kind of telling us there might not be anything different about the transmission route. There might be something different about the pathogen itself, but not the transmission routes. We get a lot of questions of, do filter bonds broke? Yes, unfortunately they did. Were they using feed mitigants? Yeah, in some cases they were. So we couldn't see that there was a significant relationship between those two factors and preventing the virus from coming, or the odds of not breaking. Maybe in some cases it did, right? So, but with our data, we couldn't see that. So the other thing that we like to highlight is that with every new strain that emerges, of course, when it goes into a population and there's not enough immunity, of course, the impact is going to be quite important. And here's another example of it, just because the economic impact was quite significant. So then when we look at the trend itself, we say, okay, how come we have seen the trend for the last 10 years so similar, and why didn't we see that this year? Those are questions that will remain unanswered for now, just because we still need to figure out whether this is related to the pathogen again, or is this related to biosecurity breaches, or is this related to something else, right? We do know that one strain was able to generate quite a bit of outbreaks, right? In one of our MSHIMP years, 15% of the reported outbreaks belonging to one strain. It's quite massive, just because we do know that every year we see the co-circulation of different strains throughout the United States. Yeah, they may have the same RFLP pattern, but now we know that we need to be careful when we classify those RFLP patterns, virus into RFLP patterns, and start referring to those in that sense. One thing that we need to keep in mind for the future is that there will always be viral activity in different areas of the country, regardless of the season, right? Yes, we know that the fall and winter are kind of the worst seasons for PRRS, not only for PRRS, but for other pathogens, as you all know very well. But I think for the sake of better communication for the future, I think that veterinarians know this very well. And yep, we continue to use our RFLP pattern, but I think we're going to move to a different classification, just so that we're comparing apples to apples. Otherwise, there's going to be some confusion that will be generated, and of course, that can bring up a little bit more questions and of course frustration with others. So I think that's an important thing to remember on a yearly basis. If you're interested in reading about this, about all the process, all this investigation, all the quantification, you can go ahead on the web. This is an open access publication, and of course you can download that and read a little bit more about it. So just wanted to highlight that part. So with that, I think I'll just turn it back to you, Pat.
Thanks, Dr. Corzo. That was a great review of what we've been seeing.